Integration using trigonometric functions. In the previous video, we studied a method of substitution for solving integrals, right? Now, how can we use trigonometric identities that we already studied in 11th and 10th and use them to solve integrals? So let's have a quick recap of the trigonometric identities that we have studied, right? So what are the different identities that we have studied? The basic ones. We'll start with sin square x plus cos square x is equal to 1. Sec square x minus tan square x is equal to 1. Then we have cosec square x minus cot square x is equal to 1. Like that, there are three identities in sin, cos, sec, tan and cosec, cot. And there are some identities, right? What are the some identities that we have studied? Sin a plus b. What is sin a plus b? It is sin a cos b plus cos a sin b. And what is sin a minus b? The same like this one, sin a cos b minus cos a sin b. And then we have cos a plus b, which is cos a cos b minus sin a sin b. And we also have cos a minus b, which is cos a cos b plus sin a sin b. So these are the different identities in sum. Now we have the sum to product. What is the sum to product? We have for sin a plus sin b. What is sin a plus sin b? It is 2 sin a plus b by 2 cos a minus b by 2. And then we have sin a minus sin b, which is 2 cos a plus b by 2 sin a minus b by 2. And then we have cos a plus cos b, which is 2 cos a plus b by 2 cos a minus b by 2. And the last one is cos a minus cos b, which is minus 2 sin a plus b by 2 sin a minus b by 2. So this is from sum to product. Same like this from product to sum also we have. I'm not writing that right now. And also we have for double angles, that is sin 2x. What are the different formulas for sin 2x? We know that it is 2 sin x cos x, or also we can write it as 2 tan x by 1 plus tan square x. So that is one formula for sin 2x. So cos 2x, we can write it as cos square x minus sin square x one way, or we can write it as 1 minus 2 sin square x, or 2 cos square x minus 1, or also we can write it as 1 minus tan square x by 1 plus tan square x. And then we move on to tan 2x. What is tan 2x? We have the formula for tan 2x as 2 tan x by 1 minus tan square x. So this is for double angle. And now for double angle, same like that we have for triple angle. And these are the different identities and trigonometry that we have studied in previous classes, right? Now, how can we use them to solve integrals? That is our main concern. We just had a quick recap of all this. There are more formulas in trigonometric identities, which we are not going to discuss right now, because writing them all together will make it a separate video for trigonometric identities. It won't be a video for integrals. So what I'm going to do right now is I'm just going to discuss these different identities, and there are many more, and how to use them in integration. Okay. So moving on to integral sin x. We know that integral sin x dx. What is integral sin x dx? It is nothing but minus cos x plus c. But is that the same way that we can integrate integral sin square x dx? Is it the same way that we can integrate sin square x dx? No. Same like sin x dx, what will be the integral of sin square dx? It will be cos square dx. Definitely not. There will be a different way to use, there will be a different way in which we can find out the integral for sin square dx. And what is the different way? That different way comes from the trigonometric identities. Now, what are the different identities that I will be using here? Look, we know that 1 minus cos 2x is equal to 2 sin square x, right? We have studied that. 1 plus cos 2x is equal to 2 cos square x. That also we have studied. So sin square x can be written as 1 minus cos 2x the whole divided by 2. Yes. So you know that sin square x can be written as 1 minus cos 2x by 2. So this is one way in which I can write this sin square x dx. So sin square x dx can be written as integral 1 minus cos 2x by 2 dx. Now can take this 2 outside. I will be getting 1 by 2 integral 1 minus cos 2x dx. And what is the integral of 1? It will be x minus what will be the integral of cos 2x? What will be the integral of cos x? It will be sin x. So what will be the integral of cos 2x? It will be sin 2x. And the same chain rule in differentiation we multiply that. So here using chain rule we get 2x derivative as 2, but here we will be dividing that. So you can write it as minus sin 2x by 2 plus c. So the final answer we can write it as x by 2 minus sin 2x by 4 plus c. So this gives us the integral of sin square x dx. And what have we used here? We have used a trigonometric identity, right? We have used a trigonometric identity that we have already studied in previous session. So this is how, or this is one way where we can use the trigonometric identities to solve problems. Understood? Now what will be the integral of sin 3x cos 4x dx? What will be the integral of sin 3x cos 4x dx? How can we find the integral of this particular function? Again, look here. I cannot directly use product rule. I don't have a product rule right now for integration. So I cannot use that. But I know that 2 sin A cos B. 2 sin A cos B can be written as what? Sin A plus B plus sin A minus B. So how can I write 2 sin A cos B? I can write it as sin A plus B plus sin A minus B. So here there is not 2. So I'm going to just multiply and divide it by a 2. So when I do that, I get half of integral. What is 2 sin 3x cos 4x? It is sin 3x plus 4x plus sin 3x minus 4x dx. And that is half of integral sin 7x then plus 3x minus 4x is minus x. And we have studied what is sin minus x. It is minus sin x. So you can write it as minus sin x dx. So finally you get half of, what is the integral of sin x? Sin 7x, it will be minus cos 7x by 7. Chain rule, but you have to divide. So minus cos x by 7 minus sin x. What is the derivative of minus sin x? It will be plus cos x. So plus cos x plus c. Don't forget to put the c because constant of integration is very important, and this gives us the final answer for the integral sin 3x cos 4x dx. So that is how we use again trigonometric identities to solve this particular integral. Got it? Now there is another question, that is to find the integral of cos 2x minus cos 2 alpha by cos x minus cos alpha dx. So you have to find the integral of cos 2x minus cos 2 alpha by cos x minus cos alpha. How can we do that? What is the way that we can do this particular integration? So to do that, I cannot directly divide cos 2x minus cos 2 alpha by cos x minus cos alpha. I need some other way. So what is that way? We know that cos 2x is nothing but 2 cos square x minus 1, right? Yes. And cos 2 alpha, same way, how can we write cos 2 alpha? Cos 2 alpha, we can write it as 2 cos square alpha minus 1. So in this way, if I write, I will be getting the numerator as 2 cos square x minus 1 minus 2 cos square alpha minus 1, the whole divided by cos x minus cos alpha dx. Got it? Now, if I subtract the numerators, inside that minus 1 and minus 1 gets cancelled, I will be getting 2 outside, and you have cos square x minus cos square alpha by cos x minus cos alpha dx. Now what is this cos square x minus cos square alpha? That is nothing but cos x plus cos alpha into cos x minus cos alpha, the whole divided by cos x minus cos alpha dx. Cancel these two, you have 2 into integral cos x plus cos alpha dx. And what is the integral of cos x? It will be sin x. So 2 into sin x plus cos alpha. What is the integral of cos alpha? Cos alpha is a constant. So what is the integral of 5? 5x. So what is the integral of cos alpha? X cos alpha. So you can write it as x cos alpha plus the constant of integration, that is c. So this is how we get the integral for cos 2x minus cos 2 alpha by cos x minus cos alpha. Here also we have used the trigonometric identity. What is that? Cos 2x is nothing but 2 cos square x minus 1. Cos 2 alpha is nothing but 2 cos square alpha minus 1. Using those identities we started, and we got the final integral value for this particular function. I hope you have understood how to use these different trigonometric identities to solve integrals. Now let's wind up the session by doing some questions. So here we have the first question, that is integral of sine cube x dx. Now how can we find the integral of sine cube x dx? Is there any direct way? No direct way is there. So what you have to use is, what is sine 3x? You know sine 3x is 3 sine x minus 4 sine cube x, right? So this is sine 3x. So sine 3x we got. Now from this, what is sine cube x? Can we write 4 sine cube x is equal to 3 sine x minus sine 3x? Yes. And from this, what is sine cube x? It is 3 by 4 sine x minus 1 by 4 sine 3x. Now if I have this thing, can I use this and put it over here? Yes. So if I do that, I will be getting 3 by 4 sine x minus 1 by 4 sine 3x dx. Now what will be the integral? It will be 3 by 4. What is the integral of sine x? It will be minus cos x. So minus 3 by 4 cos x. And then you have minus 1 by 4. What is the integral of sine 3x? It will be minus cos 3x by 3 plus c. So the final answer is nothing but minus 3 by 4 cos x plus cos 3x by 12 plus c. And this is how we get the integral of sine cube x dx. Understood? The next question, you have cos 2x, cos 4x, cos 6x dx. A product of 3 functions in cosine functions, right? So how can we do this question? In previous one, we had a question like this, that is integral sine 3x, sine 5x or something like that. So there were only 2 functions of sine. But here you can see that there are 3. So what I can do here is, I have to take cos 2x and cos 6x. So what I do here is, I take cos 2x, cos 6x. And I'm not separating cos 4x, but I'm just writing this somewhere just over here. Still the product, okay, there is no change in that. It's still the product. Now here in this cos 2x and cos 6x, I'm multiplying a 2 and dividing by a 2. So I multiply a 2 inside. So I'm multiplying a 2 inside here. So I multiply that 2 here and divide by that 2 here. So I get half of, what is 2 cos 2x, cos 6x? You know that 2 cos a cos b is cos a plus b plus cos a minus b. So I can write half of integral cos a plus b, cos 2x plus 6x, cos 8x plus cos 2x minus 6x, cos minus 4x, or it is simply cos 4x. So cos 8x plus cos 4x into cos 4x dx. Now again, if I multiply this inside, I will be getting cos 8x cos 4x plus cos square 4x. This is what I get. Now again, here I can see in cos 8x and cos 4x, I can multiply a 2 and divide by a 2. So half of integral half, what is 2 cos 8x cos 4x? I can write that as cos 12x plus cos 4x plus cos square 4x. How can we write cos square 4x? Cos square 4x can be written as 1 minus, we know that cos square x is 1 plus cos 2x by 2. So you can write cos square 4x as what? 1 plus cos 8x by 2. So that is one way you can write. So 1 plus cos 8x by 2 dx. So that is one way that you can write. And finally, half of half. What is the integral of cos 12x? I can take this one. This half and half gets cancelled and it becomes 1 by 4. And what is the integral of cos 12x? It is minus sine 12x by 12. Then half and half, again 1 by 4. So plus 1 by 4 into minus sine 4x by 4. The integral of cos 4x. Plus, there is a 1 by 2 here and there is a 1 by 2 here again. So 1 by 2 and 1 by 2, 1 by 4. What is the integral of 1 by 4? X by 4. Then 1 by 2 and 1 by 2, that is again 1 by 4 with cos 8x. So the integral will be minus sine 8x by, there is a 4. So put that plus 1 by 4. So plus 1 by 4. And then you have a minus sine 8x by 8 plus c. So just finally write everything together. You will be getting minus sine 12x by 48 minus sine 4x by 16 plus x by 4 minus sine 8x by 32 plus c. So this gives us the final answer for the question integral of cos 2x, cos 4x and cos 6x dx. So we have used trigonometric identities in a different way. That is, we first took cos 2x and cos 6x together and then we splitted it into sum. And then we again had a product again with cos 8x and cos 4x. So again we had a product and again we took that into a sum. Yes. Then we had cos square 4x. We wrote it as 1 plus cos 8x by 2. Again we took that a square or quadratic one to a linear form. And then we could integrate and get the answer, which is this one. Understood? So this is a way where we have used trigonometric identities to solve integrals. In previous session, we learned how to use substitution to find the integral value. Now we have learned also which method to use the trigonometric identities. So we are now slowly learning what are the different types of integration. I hope this session was very useful to you, and more about integrals we will be learning in the next video. Until then, keep exploring.
Manorama Horizon. Learning made simple.